Hello everyone, my name is Allie and I am the SI instructor for Chem 140 at Cal State Long Beach. If you are not a Chem 140 student, I do not recommend watching this video because the rules that they learn are slightly modified and these may not apply to you. However, if you are in Chem 140, these will likely be very helpful because it's really hard to find resources on the internet. Alright, so today we're going to be talking about ketones. And a ketone looks like this. This is the simplest ketone. This is acetone. That's a very common name for this. The IUPAC name for this is propanone. And you might be thinking, well, why don't you put 2-propanone? Because it's on carbon 2. The carbonyl, that's C double bond O, is on carbon 2, so why don't you put that? Well, if you were to put the carbonyl on any other carbon, would you still have a ketone? Let's find out. So if you have this, and if you put the carbonyl here, it looks a little bit funky. Is that a ketone? No, that's an aldehyde. So that's not it. And well, what if we put it on this side? Well, that's still carbon number 1. That's still an aldehyde. So it can only go on carbon 2. Since it can only go on carbon 2, you just need to say propanone. That's it. A similar situation occurs with butanone. Which looks like this. Butanone, the common name for butanone is going to be ethyl methyl ketone. And the reason why is because when you do common names, you name groups on either side of the carbonyl, not including the carbonyl. So over here, this is a methyl group, this is an ethyl group, therefore this is ethyl methyl ketone. The IUPAC name for this would, since there are 4 total carbons, 1, 2, 3, 4, it's going to be butanone. But we don't need to say 2-butanone, because the only other place where you could put the carbonyl would be right here. So let's go ahead and do that. If we do that, if we count from this way, that's still carbon 2, isn't it? So since either way it's on carbon 2, you can only have butanone with a carbonyl on carbon 2. Therefore, we don't need to specify 2-butanone. Okay, cool. So now let's go ahead and do some naming of some ketones. We'll do some common and IUPAC. We'll do the IUPAC ones first, and then the common. Let's see. And go ahead and name this one. We can't name common. We can't do a common name for this one. So let's just name IUPAC. I'll give you a second to pause the video and work on this on your own. Now that you've tried this on your own, the longest continuous chain is 1, 2, 3, 4, 5, 6. But there's a better way of numbering it, isn't there? You can number it this way. You want to have the carbonyl carbon be the smallest number possible. So 1, 2, 3, 4, 5, 6. I can also go down here too if I want to. See, either way, you're going to have an ethyl substituent, and you're going to have 6 carbons. So I hope that you can see that. So, this is going to be hexanone. Hexanone, that's how you do the ending name for ketone. And we have some different substituents. So let's just go ahead and look at the red numbers. I'll erase the blue ones because those aren't the ones we're using. And we know that on carbon 2, there's a methyl, there's also a chloro on 2, and then on 4, there's an ethyl. So now we just need to alphabetize these. So we will say 2 chloro, 4 ethyl, 2 methyl. Hexanone. And that's how you name this in IUPAC. In common, we can name it, let's go ahead and name the common structure of just, oh, I just did it like that, of this. The common name for this, you would name the groups on either side of the carbonyl. You don't do longest continuous chain. You just name the groups on either side, not including the carbonyl. So we have 1, 2 carbons over here, so that's an ethyl. And we have 1, 2, 3 carbons over here, that's a propyl. So this would be, the common name for this one would be what? Ethyl propyl ketone. Ketone is a separate, these are all separate words. Ethyl propyl ketone. I believe these are all separate words. But IUPAC, let's go ahead and do the IUPAC name for this structure. It's just going to be 1, 2, 3 hexanone. That's it. So that's how we name ketones. Now, ketones can do reactions. Ketones can become reduced into secondary alcohols. So if you've watched the alcohols video, you've already seen that. So let's go ahead and show you how that works. We might as well just keep the same structure up here. I'll just erase the common name. And let's go ahead and reduce this. And we show that by adding H2O on this side, I'm sorry, we don't add H2O. Yes, we do. We do add H2O. We add H2O, and we are reducing this. The reason why you need water, as I always say, H2O is better written as HOH because it helps to see the ratio of hydrogen to hydroxide. So if we go and reduce this, turn the camera over this way, we see that you draw the same structure, except for now on carbon 3, you're going to draw an OH. And what happened was, with this, is the HOH, I'll use green so we can see, the H, one of them went here, and one of them went here. The O went somewhere else. For your purposes, don't worry about it. Just as long as you know that one H went here and one H went here, and that's where this came from. Now, if we were to do the IUPAC name for this, we would say that this is just 3 hex and all, because it's now an alcohol. And this, you can see, is a secondary alcohol, because the OH group is attached onto a carbon that is attached onto 2 other carbons. That's why it's a secondary alcohol. And this is an example of a reaction of a ketone. So I think that's pretty much it. That should be able to help you out with your problems. And good luck with your studies.